So the first topic is vector. For the example, a jogger runs up a flight of 200 identical steps to the top of a hill and then runs along the top of the hill 50 meters before he stops at Dunking Fountain. His displacement vector from point A at the bottom of the steps to point B at the fountain is dAB equal to negative 90I plus 30J meter. There are three problems here. What is the height and width of each step in the flight? What is the actual distance the jogger covers? And what is his net displacement vector? So from the equation, we got the step width is 0.2 meter and step height is 0.15 meter. The distance that the jogger covers along the stair is 50 meter, thus the actual distance he runs is 100 meter. When he makes a loop and comes back from the fountain to his initial position at point A, the total distance he covers is twice this distance, 200 meter. However, his net displacement vector is 0 because when his final position is the same with his initial position, the scalar components of his net displacement vector are 0. So the conclusion, we can conclude that vectors can be used to find the actual total distance and displacement vector of the jogger covers, and also we can find height and width in each step of the flight.
Now we gonna talk about the complex number. As we can see in the screen that it was the definition of complex number. The complex number is the sum of real and imaginary number, which means complex number contains real and imaginary number. A complex number has the formula A plus IB and is commonly symbolized by the symbol Z. Both A and B are real number in this case. This is an example question of a complex number. The problem that has been identified in the question is what is the third point C, and the second one is how to represent C by the complex number. The question also want to find the complex number Z represented C in the form X plus I. In the next slide show how to solve it. This is the solution of the question. The conclusion of the complex number is we can conclude that any imaginary number is also a complex number, and the complex number is containing imaginary and real number.
Integration is a method of assigning numbers to function in a way that describes displacement, area and volume. Integration is used to define and calculate the area of the region bounded by the graph of function.
Mr. Shahrizal is a rich businessman that owned a big software company. In this past few weeks, he got headache due to so much work. He was planning on making his own healing garden, so he bought a 1 kilometer square land. I want my garden to have sunflower garden, a flowing river and a brick grass field, just like how I sketch here. But the problem is, how was the landscaper supposed to calculate the area of each of the elements in his garden? Now let's see the problem that the landscaper has to face. Problem 1. The given function for the river edge is fx is equal to x cubed and fx is equal to x squared. Which one of this function is bigger? Problem 2. What is the total area of the grass field? Problem 3. How much are the river cover in the garden? Problem 4. What is the area of the sunflower garden? Now let's see the solution for problem 1. In order to find which one of the function is bigger, first we need to find the interval. In order to find interval, we need to do y is equal to y or fx is equal to fx, and then find the value of x. With this, we know that the value of x is 0 and 1. That is the total of the interval, that is 0 to 1. From that, we can just find the value of y for each of the function. It is easy, you just need to substitute any value in the interval, such as 0.5, and then find the value of y. The ones with the higher value of y is the bigger function. From the calculation, we know that the function of fx is equal to x squared is bigger than fx is equal to x cubic because it has a higher value of y, that is 1 over 4. And then we have solution for problem 2. That is, we need to calculate the area of the grass field. In order to find the grass field area, we just need to integrate fx is equal to x cubed to get the area. Just integrate it normally with the limit is from 0 to 1. And then from that, we will get the value of the area, that is 0.24 kilometers square. And now we have the solution for question 3. For this one, we need to calculate the area of the river. In order to do that, we need to integrate fx is equal to x squared, and from that we will get the area of the river and grass field. But in this question, we just want the area of the river, so we need to minus the value of the answer that we already get, 0.33 kilometers square, with the value of the area of the grass field that we already calculated, 0.24 kilometers square, and then we will get 0.09 kilometers square as the area of the river. And lastly, we have solution for problem 4. That is, we need to calculate the area of the sunflower garden. We already know that the area of the whole land is 1 kilometer square. So we just need to minus the whole land area with the area of the river and grass field that we already calculated in solution 3. That is 1 kilometer square minus 0.33 kilometer square, and then we will get 0.67 kilometer square as the area of the sunflower garden.
From this exercise, we can confirm that we can find the area under the curve by using definite integration.